Topic 5-1, Triangle Basics. First is a couple of definitions on this page, so take some time and write these in. Triangle, a plane closed figure formed by three segments joining non-collinear points. Alright, remember non-collinear would be that they do not lie in the same line. So to sketch it, you can use a ruler if you'd like to make them straight lines. Three segments, and a segment has to be a straight line, not a curved line. Alright, labeling it is important. So if we're going to put some points on it, point A, point B, and point C, and you can actually name it with a small triangle, A, B, C. A triangle is made up of three components. The vertices, and so the ones for this triangle are P, Q, and R. So those are named, vertices are named by points. Sides have to be named with segments. Draw a line over the name to name it. No arrows, and it denotes a segment. So remember, points name vertices and segments name lines. The angles on this, you can name these angles either by its one letter or you can name it with three letters. So angle P, you would draw an angle symbol with P, or it could be angle Q, P, R. Always making sure you put the vertice in the middle, the vertex angle in the middle. It could also be, there's an angle R, could be said as P, R, Q, and then the last one you would say is angle Q, and that could also be named P, Q, R. And these could be backwards too, R, Q, P, Q, R, P, or R, P, Q. You could name them backwards. Okay, a few more definitions. Scalene is a triangle with no congruent sides. So when you draw it, you would probably want to draw a short leg, a longer leg, and then one even longer than that. And a lot of times it's good to mark these. Markings will help you denote whether it's scalene. 1 mark, 2 marks, and 3 marks. This still can be labeled A, B, C, but we know it's scalene because of its markings. An isosceles triangle is one that has 2 congruent sides, and that's usually the one that's going to be used to test. They like a lot of the testing we've been using is they use isosceles. Now that looks almost equilateral, but if it's marked with just 2 markings that's showing the same, and sometimes a isosceles will put 2 markings for the base angle. And this is actually a vertex angle of an isosceles triangle. Sometimes that's noted. So if I label this M, L, and N, you can name this triangle any way you want with the triangle symbol, but the vertex angle would be this angle. We're going to learn later that the sides opposite the congruent sides of an isosceles triangle, those side opposite are also congruent. That'll become handy in some other future worksheets. Equilateral is a triangle in which all 3 sides are congruent. So you're going to try to draw them with all 3 equal. May not be exactly because I don't have a protractor measuring each of these sides, and all the sides of an equilateral triangle will be 60 because, angles of an equilateral, but they'll be showing marks to show equality with 3 marks all the way around. So this could be triangle XYZ. So take a minute and make sure you fill in the definitions, descriptions of scalene, isosceles, and equilateral. Moving on, let's do example 1. name the triangle, classifying it by its markings. This first one, we just drew it equilateral. I-L-A. T-R-E-A-L. Oops, sorry. E-R-A-L. Equilateral. Scaling, denoted by all sides are different with the 3 different markings. 2 tick marks the same and 1 different is an isosceles. I'm not spelling correctly today. Isosceles. I-S-O-S-C-E-L-E-S. Okay, given this example, you're going to plot these points and use the distance formula to show that it is an isosceles triangle. Alright, so if we plot these points, walk over 2 and up 3, walk over 4 on the x-axis and up 3, because it would be a pretty tiny triangle, and 3, negative 2, long and skinny. Alright, we're going to prove that the distance from here to here is the same as the distance from here to here, so that we will prove that these two are going to have the same, and this would be our base angle. It is an upside down for the base, but we should have labeled these. This is our S, this is our T, and this is our U. Okay, so remembering the distance formula, you're going to take, let's start with the distance between S and U. So, remembering our formula, it would take the x values and subtracting them, 3 minus the 2, square those, added to negative 2 minus 3, squared. 3 minus 2 is 1, and 1 squared is 1, plus negative 2 plus a negative 3 is a negative 5. But when you square negative 5, I'm going to go ahead and make that the positive. That's going to be 25. So I've skipped actually showing a step, but this you can also actually put in your calculator. Make sure that all of this is going to be the square root of, this one actually is the square root of 26. So you could leave it like that. Alright, let's do the distance of ST. So you're taking, you can mark these notes, but if you'll just look up here and carefully stay with the same one, let's start with 4. So 4 minus 2 squared, and add them to the y's, 3 minus 3 squared. That's going to give you 0, and this is going to give you 4. And let's go ahead and show that. This would be 2 squared, which is 4, and this is 0 squared, which is 0. You're adding those two together. Well, the square root of 4 is 2. Okay, we've got one more that we're trying. This is going to be the distance from S to T, so this distance we could have done just by looking at it, counting 1, 2, but confirming it with the distance formula. Okay, T U is going to be the square root of negative 2 minus 3 squared plus 3 minus 4 squared. This is going to give you 25 plus 1. Take the square root. You'll see that it's also the same as that. 2 square roots of, showing that SU and TU are both square root of 24, proves that this is an isosceles market triangle. Okay, so several things to just make note. The sum of the measures of the interior angles of a triangle are 180. You will use that knowledge over and over again. If I were to add all of these angles, 180. Adding all of these angles, 180. On an equilateral, all of these will be 60, because 60 plus 60 plus 60 would give you 180. The triangles can also be classified by the measure of their interior angles. let's move on to example 3. Actually, before example 3, some more definitions. Let's do a few sketching. Alright, acute angle, one in which all three angles have a measure less than 90. Alright, we're talking about an acute triangle, but let's go over an acute angle. If this is 90 degrees, I'm just showing that with a protractor, 90 degrees, every angle that I show to the right is going to be an acute angle. No matter how small or how big, these angles underneath this green line would be acute, all the way until it becomes straight up 90. So when you draw the sketch of this, all of your angles would have to be smaller than 90 degrees. So everyone inside, doesn't matter whether it's isosceles or equilateral. We're not measuring it that way. We can put several different values, but everything inside of here would have to be less than 90 degrees. So this could be 35, this could be 50, and this could be 65. That would give us 180. An obtuse, think obtuse, really big, a triangle with at least one measure greater than 90. Obtuse, if this is 90 degrees, everything that would be larger than 90 degrees measured with a protractor going all the way to a straight line, up to a straight line anyway, would be an obtuse angle. So you'd have to have at least one that would have an angle greater than 90 degrees. So when drawing it, try to make this a larger than 90, at least on one side. So we could say that this is angle is 100. That would be larger than 90 degrees. And this would be 40 degrees, and this could be 40 degrees. A right triangle, you would want to draw one straight up, perpendicular line, straight across. Triangle that has one angle that does measure 90 degrees. This is always noted with a box. So we could mark that as a 90 degree. This could be a 60, and this could be a 30. An equilateral triangle, we mentioned earlier, is one that has all equal measures. So if they're all equal measures, they all would have to be 60 degrees. So every equilateral triangle would have 60, 60, 60. So you could show those with curved lines all being denoting that they're equal. So if I put one as 60, all of them would be 60. All right, examples. Here's one that's 60, 60, 60. That is an acute, because all of them are smaller than 90 degrees, equilateral. I'm sorry, equal angular. We're talking about angles and not sides. This one, we could call this, they all have different measures. So this is an acute. This is an obtuse with one angle larger than 90. Because it shows a box, that's a right angle. So find the measure of the third angle of a triangle whose first angle has a measure of 66, the second one that has a measure of 37, and we don't know what the other one would be, so adding those together, 66 plus 37 plus what we don't know is all equal to 180 degrees, because we know all the angles equal 180. 66 and 37 is 103. We don't know what that's added to, so you're going to subtract 103 from 180, so x would be 77. And you can use a calculator for these. Okay. This is two more pages. Example 5. Find the measure of each of the angles of RST. Okay, so we know that all of them have to equal 180. So let's combine all of our angles that have common terms. There's an x, there's 3x, and another x. So that's going to be 5x's plus the 40 is equal to 180. Subtract 40 on both sides, you get 5x is equal to 140. Divide by 5 and x is 28. So if x is 28, then s is 28. But r is not 28. You would add 28 plus, oh I'm sorry, r, 3 times 28, which is 84. And this one is 28 plus 40, which is 68. Find the value of this one. Well, if they all have to be exactly the same, try to remember that. They're all equal to the same thing. So 3 of my x's have to equal 180. You divide 180 by 3 and you're going to get 60. One to memorize. An equilateral, equal angular triangle will always have a measure congruent, shown a lot of times with curved marks on every single angle. The triangle in example 6 is an equal angular triangle. Based on this example, we can say that each of the angles of an equal angular triangle is 60 degrees. Note this one, we know this one right here, because of its box, is a 90 degree. So if we needed to add all of these up and set it equal to 180, we have 2x and 3x, so that's 5x. We've got 90, 92, 93, 94, 95. So we've got our value over here is 95. Oh, I don't know why I put 1800. It's only 180. Okay, so if you've got, let's see, 95 subtract 180 is going to have 85, and 5x is equal to 85, so your x is equal to, when you divide by 5, 17. So you still are going to do this to find out what each one of are. If you needed the measure of angle J, you would just plug in 17, multiply by 3, and add 2. If you needed to know angle L, you would plug in 17 times 2 and add 3. Alright, last examples and a few more notes. J and L in example 7 would be classified as acute angles. Since the sum is 90, we can say that an acute angle of a right triangle is complementary. An exterior angle of a triangle is formed by one side of a triangle and the extension of an adjacent side. That's a lot to say, but know that adjacent sides are ones that share a ray and sit next to each other. So this is the adjacent side to one. Finding the measure of this exterior angle requires you add this angle plus this angle. And I have shown this before using some patty paper. Let me do that real quick. If I were to take this angle, turn it around and add this angle to it, so that I've taken this measure and this measure, 80 and 40, this whole measure here, slide over, would be the measure of angle 1. Angle 1 is your exterior angle. So when we think about exterior angle, that's the angle. You're adding these two together. So when you add 80 and 40, you get 120. So the measure of angle 1 is 120 degrees. Alright, so we could do this one. If they tell us that angle X in triangle XYZ is 63 and Z is sorry, they didn't tell us that one. YZ is 53. If we add 63 plus 53, you're going to get 116. You take 116 and subtract it from 180, you'll get the measure of that other angle. So the measure of this angle is 64. Alright, so they want ZYR. ZYR. Since I've been coloring those, let's color that. That angle right there is the one they want to know. Well, this angle can be gotten by adding these two angles together. You could show it again. Ask your teacher for some patty paper if you want to trace this to make sure you understand that. Oops, remember your little degree symbols. So if I add 64 and 63, 64 plus 63 is going to give me the measure of angle ZYR. And that is 127 degrees. Okay, one more. G is 100 degrees. And FEH, this time they actually give you the outside one. And they're telling us that this is 3 of angle F. Well, let's see, we don't know what angle F is, so let's give it a value of an unknown. We don't know what this one is, but we do know that this is 3 of it. So, like the measure of angle F, we're giving it a value. You can give it any kind of variable you want, but a lot of times we use X. So if you're needing to find that, then you know that 3X is actually your total. It's equal to the 100 plus X. Subtract X on both sides, and you're going to have this go away. This becomes 2X is equal to 100, so your X is equal to 50. In this case, X is the degree measure, so we don't have to plug it in. It just becomes the answer, 50 degrees. And that concludes section 5-1.